Okay. Hello, everyone. My name is Murad Bouache. I work at Verizon. I work at Performance Engineering Group. And last talk was about science of performance, which I believe that it's science. I have been working for performance for more than maybe 10 years between academia, research, and industry, or a corp with Yahoo, Oath, and then after this with Verizon. Today I'm going to talk about the good profiling habits, which means what you need to do for profiling when you have bottlenecks or performance bottlenecks, performance issues, how you can handle it, how you can find it first, and then how you can fix it, and then how you go further and tune the application or program or system. So as I said, it can be a book, Science of Performance, and maybe the chapter one is going to be profiling or profiling habits, or good profiling, or cool profiling habits. I like the title. And it can be different other chapters, benchmarking. People who attend the previous talk, I went through all different chapters or different topics related to performance. So this is the mission of the performance engineering group at Verizon. So when we have an issue with performance, developers or the manager of the product or the service came to the Verizon PAG or the performance engineering group, and then claim that there's an issue, and then we need to try helping them to determine the issue. It can be hardware or software. Today I'm going to talk mostly about software, maybe another chapter about hardware performance. Today is software, the most complicated in my opinion, because it's more dynamic and also it depends on the developers, habits, how they are programming, good programming, bad programming. But software issues or in performance are the most difficult and complicated. We do the software issue, we find the software issue, we do code analysis and code profiling. We analyze the code and do the code profiling. Code profiling can be with different tools, different packages in Linux or in-house that we developed at Verizon, at the Performance Engineering Group, or we use external like Intel VTune Amplifier. The agenda of today is going to be about software performance, profiling process, what's the path or what are the steps, the pipeline of profiling. Intel VTune Amplifier as the tool that is helping us a lot to profile our code or application or services. How we do the data collection with the Intel VTune. We do actually some demos, one for a simple just hotspot collection, and then another one about the locks and waits. We are not going to go deep on how removing the lock, because it's complicated just to remove the lock and then see the rest of the system or the entire system. But we are going just to comment, we'll see this on the demo of the locks and waits analysis. VTune for Java application, we saw that there's a huge increase of programming language jumping from C, C++ to Java application because of the garbage collection and mostly dynamic memory allocation. More profiling tools, and then at the end we are going to get a conclusion as good or cool profiling habits. So the software performance is part of the science of performance. And there is also the hardware performance. And mostly it's about profiling and benchmarking. We talked about what the difference between profiling and benchmarking. Profiling is more about comparing, and benchmarking is more about evaluating the service or the application. For example, we have two technologies and CPUs. We do benchmarking to understand which CPU is the best. Profiling is more about code analysis and optimization. Monitoring is about looking at different systems in our data centers and see if there is all the systems are good, are healthy. Profiling tools are the tools that we are using for profiling, and then performance tools, it's kind of profiling tools, but including also everything which is connected to the software performance. The profiling process, I always say that just, first do not harm means that just start slowly. just to start with a basic thing. Maybe the problem is really easy and you take it as complicated, or the problem is really complicated but you think that it's easy at the beginning. After figuring out that it's not a hardware issue, then you go to the jungle of the software profiling. You start with the basic analysis, means that use simple tools like top, uptime, just for observation, and then jumping on to the intermediate tools like SAR, to just specify if what's the component exactly on the server. If it's about the memory, then we do the memory profiling. If it's CPU, then we do the CPU profiling. Understanding which component is helping a lot, and I think it's more than 80% of the solution. Advanced analysis, here you need to understand that everything is with a cost. If you do advanced, means that you need to pay for it, and the pain in performance is either going with the overhead, or actually you buy new hardware, which is more expensive. And so be careful with different packages or application or tools that you use for advanced analysis. And we'll see that VTune has maybe a low overhead when it comes to general exploration or hotspots analysis. But when you go to logs and weights, then you are going to pay for the 5 to 15% of overhead. And sometimes you start thinking about maybe VTune in VTune. I always I always say this, and there's one of the guys that he's the godfather of VTune. Gary is here, and we had this discussion before, and it was funny. But we'll see how we can get there. So more details, it means that you have more impact on the system. This is just a simple performance script where you just go through the CPU, memory, file system, disk I/O, and network. And it can be helpful just starting and understanding where is the problem. If it's on the CPU or memory, on the file or the I/O, or maybe the network. If we go with the system, the whole system that we have with different layers, where you have the application, the operating system, the system calls, and then maybe the TCP and virtual memory, Ethernet, different drivers, and also the hardware. Every piece in this system, in this ecosystem, you have different tools that you can use. Sometimes it's good that you have all these tools. Sometimes people, they are confused. Which one is the best? Why I need to use this and not that? And actually, VTune is kind of helpful in this way, because everything is in one screen, in one interface, that you can see everything, and you can go with other tools that can be helpful. This is why today I'm going to talk mostly about VTune, how we can play with how you can play with the tool, and then you see how you can analyze the data and monitor all different data. So going from the user mode to kernel mode, you have different tools that you can use. And on the application, I would say that VTune Amplifier is a good example to start with, and then see how it's going to be helpful for you. I did a survey and see how many actually for Java application, because mostly it's Java developers. We have more than maybe 80% of developers at Verizon. They use Java for different application, front end and back end. So VTune is more than 47%, more than 40%. We have actually 47% in this survey that they are using VTune, but at the same time, people use different other tools for Java profiling, and essentially for garbage collection and memory profiling for Java applications. So let's return back to VTune or the amplifier. VTune, the Intel VTune analyzers or amplifier. Why analyzers? Because you have actually different things, different analyzers within the same tool can help you locate and remove the bottleneck of your software or application. And it comes with by collection or by collecting the data, analyzing the data and displaying the system-wide performance. And you can go even to the source code and see where is exactly where is the line is maybe spending most of the time in the CPU. So this information is helpful in understanding where is the issue, and then help you how you can remove the issue and then maybe tune it in the future. So the information that we can get through VTune. We can get from VTune. It's CPU hotspots, locks and waits, memory access, which is very, very powerful for cache misses and so on. Flops or float point operations, and also storage access, wait time, OpenCR kernel tracing. All these things, all this information that maybe you can use different tools at the same time to get this information. You can get them in VTune. This screen is actually one of the most, if you are familiar with VTune, for sure you are used to this screen, this picture where you see the top-down tree tab all the time to see what are the hotspots, for example, for this source function stack. And then actually the top-down tree give you the hotspot functions, the call tree, and then give you all the metrics or the performance metrics for different functions that you have. It's really helpful, and you can see in one screen different metrics that you have and the function, and then numbers. For people who are in performance engineering, they understand it. For developers, it's a little bit complicated, but actually there are some tabs specific for developers. And usually what we do at Verizon is just try to explain what are these numbers if they don't understand them as developers, which is normal. Or sometimes we just meet them and then talk to them and then tell them these are the red flags and this is the way how you do it to tune your application and make it better. The steps and the features on VTune, usually you start with when you start with the VTune amplifier, you have the GUI usually installed in your desktop to just monitor, see or analyze the data that you have, or you can do the command line in the collection. You can do the same thing on desktop too, but usually what we do is command line in the server remotely, or you can connect through your desktop to a remote server, connect and then collect the data. From the Studio package, you have the Intel Power Studio XE, the system, and then you have the Media Server Studio. If you have a Microsoft server then, or the desktop, then it can be integrated on the Microsoft Visual Studio. How you do the configuration and the render analysis, as I said, you can do it in localhost, you can do the remote system, Android device if you are talking about mobile, and what's profiling the application, the process of the system. Application means that you profile the whole application, the process, you attach the process to any specific command line to do the collection analysis. And system, same thing, you can do the collection of the whole system. How these are the type of the analysis that you can do, the hotspots, microarchitecture, you can find the performance counters if you are a hardware guy or performance engineer. You can check the parallelism in your application and also the platform analysis too. Analyzing the data, it can be on your desktop. Also, you can get a report when you finish the collection on the remotely, on a remote server. A small report, you can just finalize and then copy the data, or you do it remotely from your desktop to see in real time what happened on your server. It can be a source code. You can go through deep on the source code or assembly on a specific function or a specific code that you already profiled. The collection, it's a simple process. You just create any benchmark or application. It can be a real application or anything just to test it. A second step is collecting the data. You analyze the data and you find the issue or try to identify the performance problem. You fix the problem in your code. If it's not fixed, then if the problem is fixed, then your performance requirements are met or not, or as you expect. If not, then well, you have optimized code if everything is fine. If not, then you go through the loop and collect, reproduce the same thing, and then fix. If it's not fixed, you do the same thing from the system to application and processor. And any question to developer, it's a good question, because people, usually we just go and jump on profiling the code and without asking questions to the developers. Sometimes developers that are lazy to tell you that they changed the code, they did some update on the code because they don't want to repeat or do the same thing again. So any question to developers is very, very helpful when you are using the tool. This is the, actually, this is the topology that we have with VTune at Verizon, where we have different data centers or one data center with different type of servers, Ivy Bridge, Sunny Bridge, or Skylake server. And then we do the collection there means that we install the collectors everywhere on our server. We don't do it by default, means that when we install the system, it's just when we start having issues. When we have a report from the developers that we have issue, then we go and install the collector. And then we have a server, a big server, especially with the storage, which is very important, and the compute where you do, when you finalize your collection, it can take a lot of compute, which we call the admin server for VTune. And then me, for example, or any performance engineer can see or do the monitoring. Sometimes we did the training, a lot of training for developers. We have a lot of developers that they know how to monitor the data collected through VTune, which is very, very helpful. Okay, the type of analysis on VTune. So we have essentially three, and sometimes it's more because of the new version of VTune and how folks at Intel, they see the thing, how if it's important to add a new type of analysis or not. But essentially, this is the, we have the hotspot where you identify the section of the code that took most of the time on the CPU or for execution. Concurrency, as the word said, it's this processor utilization, the hyper-threading, different cores, different threads in parallel, and logs and weights analysis when you have an ineffective processor utilization with synchronization objects. Any questions? No questions? Okay. I want to give more light for logs and weights because it's more complicated. I think it's the most complicated analysis, and also it's the analysis that takes more overhead if you try to do collection, because you are doing some instrumentation, which means that you are adding some extra code to your application or code for counting, like counters and so on. So I would like to just to give more light, and the demo is going also to, I'm giving a demo about this logs and weights too. So you create your project on VTune. After building your application, you run logs and weights analysis, and then you try to interpret the results, and sometimes you go even to the source code and try to find the logs, and you compare with the previous result if you have, and see if you have some improvements on your code. Same thing as collecting any data, but for logs and weights, it's about removing the log, which can have a huge impact in performance analysis, and then you build your application and you do the loop again, same thing, compare it before and after, before versus after, before versus after, until that you got very good or the optimization or the performance you are expecting. So logs and weights analysis helps to identify the cause of the ineffective processor utilization. Trying to removing the log is going to optimize a lot of stuff. These are the features for the VTune Amplifier 2019. I think the biggest thing is supporting Java application, and also maybe some new type of analysis that Intel added on VTune. Also the connection of VTune for different other environments, like VTune for containers, VTune for VMs. These are the things that Intel added on this, which are very helpful actually. Now the overhead. So VTune has by default a low overhead. The only thing that it can improve your overhead, the 5% to something else. As I said, it's about the instrumentation process that you can do, or the counters, or adding in general a code in your application. And the Intel, why this low overhead by default is because Intel has specific chip, the chip performance monitoring unit, or the PMU, is very helpful because it's purely hardware tool that can help sampling or collecting the data, and this ensure this low overhead on the system. And the sampling resolution, it's by default every 10 milliseconds and collected by the PMU. And the sampling, it's through the SEP, or the sampling collector, which is also a product from Intel that can help help in the type of sampling that you do. Also, there is a call graph too that can helpful to see the caller and callee. We'll see this in one of the tabs on VTune interface.
Question.
Tell me.
Sampling driven by operating system or by hardware?
Not operating system. You cannot do anything in the operating system. Actually, this is the hardware.
Internal interrupt and scan.
Yeah. This is all about, the sampling is all about the performance, the hardware performance counters.
I mean a time regulated by operating system, so it's a timing interrupt, or it's just hardware has capability to
Okay. So the command lines that we are going to see, it's actually the user who is going to fix the duration of the sampling. So you do a duration of 10 seconds, and it has huge impact also on performance too, and also the overhead. There's also the granularity of your sampling too. There is between low, medium, and the high granularity, and this will give you more information, representative information. But it depends, actually, it depends of the application. Some application, if you go with the medium, it's good, you get all the information you need and you fix a problem, and sometimes it's not. So it's the user who is going to fix that. So the main focus here, we are going to talk about the CPU usage because how you can reduce CPU usage while we are executing our application, how we can make it faster with using different application threads. And this is actually the most interesting thing and the most important thing when we talk about the CPU performance. Always, we take the process. I give you the best, actually the best experience I got through using the VTune is don't go right away to logs and waits. Start to do general exploration, low overhead, hotspots after that. If it's not enough, that hotspot with memory information, and then go to logs and waits when it comes to a log issue. General exploration, it's understanding the code passing through the core pipeline, which means that you have this two histograms of the CPU, and then this will give you idea how many cores, how many threads are used by your application. And the average is going to be the point that you need to push maybe to the orange, which is okay, or ideal green. 24 is the target concurrency, which means the number of cores you have, number of threads you have, 24. And then the average is always trying to push it from poor to okay or ideal. To be honest with you, I rarely see the ideal. The green number of threads, I think I never see that. I mean, I didn't see that before. Usually we are working between the poor and okay. And this is the, I think, the big issue about parallelism and the bad programming for developers. I mean, it's a common issue with the high-tech companies. Comparing different hosts, it's very, very helpful. It's very powerful because you can actually compare the previous situation with the new situation. Let's say you have an issue, you get your host, and then you take another host, and then you do your improvement, your tuning, and you compare it to the previous one, which was the same situation, and you can see this. And this is very good scenario where you started from maybe the average of 8, between 4 to 8 threads, and you go to maybe 20 to 24 threads that you're used by the application. And the ideal, and here we are targeting 32 threads on our CPU. Hotspots. Hotspot analysis locate actually the top functions used by the CPU, or they spend most of the time on the CPU. Everything when you see red means that it's bad, it's poor parallelism, poor CPU usage, and you need to work on this to take advantage of the threads or the cores that you have on your server. But these are the hotspots that he got. But I see, it's the hotspot view for general exploration analysis. Locks and waits, these are the synchronization objects for a real application at Yahoo or Verizon. And then the logs, it's about finding the synchronization objects that affect the performance of your system. Here we have small orange things which gave us hope to improve their performance. And for this specific application, actually, we went until getting mostly orange, which was actually very good in wait time by utilization. Here another logs and waits, just to explain when you click in one function on the left side, you can get the details, and then you can, when you share this with the developers, they certainly know about what's the function and what the function is doing and why we are having this issue, which is very, very helpful. And this, for this specific one, is wait time and the wait count. Here you can check the source code. You can click in any function, and then you got the source code here. If you click at the red red color, then you just jump on exactly the line that you have on the source code. You can get it as C, C++, or Java, or you can go to the assembly for people who understand assembly language. Okay, this demo, demo number one is going to be just an easy hotspot analysis with specifying the simple directory. So when you install VTune in your server or in your desktop, it's going to install it by default in OPT Intel and then VTune and then the version. Here I installed the latest version of VTune, and I took the matrix application as an example. We are going to see, this is the result that we got, how many threads we are using with the CPU histogram. But we are going to collect the hotspot actually analysis. We are going to do a hotspots analysis. And when you install, when you finish, and then you set the environment of VTune, you'll get the amplexc-cl and then -collect hotspots. Sometimes it's changing, sometimes advanced hotspots, sometimes it's hotspots. I thought that it's advanced hotspot. Actually, they changed it to hotspot, that's it. And then you have the duration I was talking about, the duration of 120 seconds. -R is going to be the folder where, or directory where you are going to put your data or save your data. And then you attach it to an application, which is Matrix here. Let's try. Hopefully my server is still connected. Okay, let's see.
So this is asking the VTune to only dump information about hotspots, so you can run other analyses based on this run. Is that right?
Yeah, this is just an example of hotspots.
Okay, but this will change the actual counters that are read from VTune. Is that right?
No. The hotspots is just collecting the data and trying to list all the top functions.
Right.
Spend most of the time on the CPU. What's your question?
It changed the information you dumped, right? It changed the information that the profiler dumped on the files on your disk?
No, it's not going to change. It's just going to save the data, the instrumented data.
Right.
Or
that will just be hotspots. You're not actually saving the counter information or
No.
anything like that.
Well, it's going to take all the hardware performance counters. This is the idea, is to take all the hardware performance counters, put them in specific interface, and make them clear to you. If you do the same thing with perf, it's going to give you the same thing. It's going to list all the function, the top function that is spending most of the time in the CPU with the numbers that you specify. For example, hotspot, Intel did some specific
But this command line is about running the application, right?
Yes. Yeah. Let's see.
And I think where you were going is the amount of data collected
Right.
in the hotspot analysis is a subset of what would be collected from general exploration.
Right, because we didn't ask for logs, for example, it would be less data on the disk, for example. Right.
Actually, if you do the logs, it's going to be more data.
Right.
Right.
It depends.
If we ask for both, it would be even more.
Exactly, yeah. So the first thing you do is you source your environment. So you set up your environment, you source Intel, and then VTune, and then actually here is going to be Amplexi, vars, sh, and then done. Here, when you have the copyright and the version of VTune, then you're good. And then what you are going to do is run the Amplexi. So when you do Amplexi CL, then you see it. So everything is fine. Then you do dash collect. And after this, you do hotspots. And then actually, let's go to the samples, right? So when you go to the samples, which is in OPT, Intel, and then go to VTune. Don't know if the samples are here. Yeah. Samples, English, C++. Yeah, you have our metrics here. Okay, so we do Amplexi here, cl-collect, and then hotspots-r. We'll do it in home, Murad, hotspots 3, because hotspot 1 and 2 I tested yesterday. And then actually before the R we do duration. We do duration of, let's say, 10 seconds. Okay. And then we do matrix. Let's see how this will work. Looks like everything is fine. Just to make sure. R, good. Duration is with 2 dashes. Because I don't see the actually. Okay. Yeah. Yeah, so this, yeah, actually the command line is, we are collecting the data right now. So it's running the application, collecting the data, and then having this report. It's fast, because it's only 10 seconds. You can go more than that and see how, for the duration, how it's going to take. Well, also it depends on the application. If the application is fast, then we're good. We are at, I think it's a Cascade Lake CPU, right? Or a Skylake CPU server. Yeah, Cascade Lake. Yeah, we are a Cascade Lake CPU. So here you have the basic report. This is the thing. You have this basic report. You can, save it as a report, and then use this if you're happy with it. But the best thing, the best report, the biggest report is actually when we did this this command line. So we saved the report. Remember, in home, Murad, and hotspot 3. We just take the hotspot 3 here. I did it before. So let's say we go to hotspot 3, cd home Murad, hotspot 3. We have this, actually the folders. We have the archive, config, data, hotspot 3.amplexy, log, and SQLite DB. This is the file that is going to open, that you need to open your desktop or monitor in your computer. So this is, so after finishing the collection, just go to your desktop version of VTune, and then here, if you want to create a new project, or you just go and then open analysis. Sometimes you have a recent project here and recent result here. But if I would like to open the analysis, let's say this is the folder that I saved in my server and copied in my computer. You just compress your folder on server and copy it in your computer, in your desktop. We open the hotspot2.amplexy, and this is how we got the information. It's running, the elapsed time is 5 seconds, and then you have the CPU time of 78 seconds. The total thread count is 17. So when you count it here, you have 17 threads from 0 to 16. And then this is the summary of your data collection result. And then you have the top hotspot. We see the function matrix is the top hotspot here. And you have some libraries that are connected to the application. Sometimes the library from the operating system, like libc here for the C language. And other modules that that sometimes they are known by but when you click on the hotspots, you have directly the bottom app tab that you see, and then you have the CPU time, you have the module, you have the function, the source file, and then the address on the memory. Sometimes it's not figured on your tab. You have the effective CPU utilization histogram, which means how many threads you are using in this CPU. We have 72 threads CPU. I think it's Cascade Lake CPU here. 72 threads CPU, 36 cores, Cascade Lake CPU. The collection and platform information is really helpful. Why? Because when you run your VTune in different servers, this will give you the specific server, so you are not going to be confused. And actually, we are waiting for the next version from Intel to be more creating like a server where you can manage all this database, different servers, where you run your VTune in different servers, and then you have a collection with the ID of your server and the result that I have. I click on the result, and then I got all the details in my desktop or in the server side. So don't ignore the collection information here, because it's giving you the type of your CPU. It's giving you, see, here, for example, yeah, it's a Skylake CPU. It's a Skylake CPU here, 2.3 gigahertz, and then 72 logical CPUs or threads. When you go to the bottom up, as I said, you have all the functions that you have. Actually, here you can do the hotspot by CPU. You do the threading efficiency or HPC performance characterization. Here it's going to be more, I think, more about the hardware. Yeah, here you see the GFLOP and the SP, the single precision, the double precision. If you go with threading efficiency, it's going to give you more information about threading, how much threads you are running, and how much you are taking advantage of your resource in terms of CPUs and threads. Let's return back to the hotspots. We go to the bottom up. The bottom up, you have all your functions, and then you can click, as I said, and then you have more details about the functions. The threads are down here. You can count the threads, how many threads. The good things too, here you can specify which process. Down is if you're going to be 100% matrix, Or you can specify the thread. If you want to get specific thread, you just click in one thread and it will give you only this thread. And then the good thing is that you can select and then you zoom in selection. This is very good because sometimes with Java application, garbage collection, you just click and see what happened before and after. Filter by selection, filter out by selection, zoom. This is really good actually feature. When you are done with it, just return back and then do init thread to get all the information back. Caller and callee. This is really also a powerful concept or feature where you see all the caller and callee function, who is calling who, and this will be very helpful if you have an issue understanding who is calling this specific thing in this specific function, and understand how you can remove the issue in the caller or in the callee. Top-down tree, same thing. You have the total, and then you go down, and down, and then down. This is the simple example, but in the very real application, believe me, you get sometimes you don't have space to see all the details here. The platform is all about the seeing that sometimes you have the threads with the frequency, different details that they are very helpful. Frequency is good because before Intel used to do actually the collection only for frequency, and we can see this on one of the slides I have. But it's very helpful because sometimes you have some concept which is throttling or thermal issue where the frequency is not hitting exactly what you are looking for as a frequency set by Intel. So then you go with a problem with the frequency, and it has huge impact directly into the performance. Okay, any questions? Yes. So this is the time. Yeah, that's a good question too. So some of the threads, they run only for a few seconds. So here, for example, it's even less than 1 second. This is 0. And this is like 0.27, and the biggest, actually, the highest one is this one. And this will give you idea about the red zone that we have here. So here we are still even at the beginning of thread. Means that we are not really taking advantage. This is I think it's a single thread. Well, you are using different other threads, but you have only one thread where you spend most of the time, which means that you are not taking advantage of the number of threads you have. This is not the best CPU for this specific application, I would say.
Looking at this, it looks like you only spun up 16 threads when you could have spun up 72.
Yeah. Yeah, we use here only 17 threads, but mostly one thread maybe at 4 seconds. Okay, back to.
So then if we need to kind of do some optimizations and stuff, so will this be able to also give us some pointers as to do this?
Yeah, I have an example about logs and waits. It's for the second demo, because Steve actually suggested to give more demo than explaining things just on pictures, which is very good. So this is just to show you the environment of VTune, the interface. Be familiar with it if it's the first time. If not, then I'm going to show you another. So the idea here is just how you run your command line, how you collect the data. Now optimization, all the deep things that we are going to see in VTune is going to be as a next step. So yeah, you have this report and result, which is almost the same. I mean, when you see it in your desktop and you see it here for this very simple application, then it's kind of enough for me. When I see it like this, it's kind of enough for me. But sometimes this is not going to be enough. I need to get more details, more information. And the good thing, I think, just remember that the perf data can be imported to VTune. So the perf that you have And if you want to take advantage of the interface of VTune, you can just import it. There's some issues sometimes, but you can import actually the data that you collect through perf. So logs and waits, this is the command line. You just do the Amplex CCL, collect logs and waits. You specify the duration in seconds, and then where you save the data, and then usually logs and waits, actually you attach to the process, and you need to give the target ID of your process when collecting the data. Okay. Now let's go, I'm going to explain here, but at the same time I have actually one example with the logs and waits. So logs and waits summary, you have more information. You have the elapsed time as we saw it with the hotspot. You have the wait time, you have the wait count. Who's going to tell me why the wait time actually it's bigger than the elapsed time? Yeah, why you have 739 wait time, and they have, and it's bigger than the 26. I'm running only for 26 seconds here as a elapsed time. The CPU time is 14.
Is the multi-threaded?
Yes.
That's
Yeah.
related.
Means that, exactly. So it's time by thread. Time per thread, if you accumulate this, then you get the 739.101 second. So the total time of application run for the, including the data collection, the wait time is when the thread is waiting, and then sometimes you have API, block, or the synchronization objects. The spin time, where the CPU is spinning, means that it is not doing anything, waiting for something, and the pipeline means that you have some dependency in microarchitecture, or some instruction is waiting for another one, or some instruction is waiting for the result of a previous one. And then it's actually a huge performance issue where your CPU is spinning, and this is why you have the red flag. So when you have a red flag on this summary, when you are doing any analysis, means that you need to take a look, and when you click, actually you have the details of the spin time. Now the CPU time is the time of the CPU spending of the executing the application. Here we have all the synchronization objects. When you do logs and wait analysis, the result that you have is about the different synchronization objects. You have your critical section, the semaphore, all the mutexes and stuff. So it's all here. For example, we have the critical section at the top of the functions, which means there is an issue. You need to find a log. And remove it, and then tune the application to fix the issue. And this might help improving the performance of your application. Okay, let's go back here. Let's say I collect the data the way I would do it with this specific command line. And then I'm going to my monitoring system, or VTune monitoring. And then I will go for the logs and waits 0 and logs and waits 1. So this is the previous one. So when I did the logs and waits, I got the same thing. And the threads concurrency histogram, it's also pure, maybe idle CPU utilization, which is very, very bad. It can be the same after, but our issue here actually how we can improve the performance, finding the lock, and then removing the lock, and try to move this critical section as top functions on the synchronization objects to another order. Okay, so we saw the bottom up. We can see the bottom up 2 here. You have the threads. Sometimes you can see that you are not really running your, the CPU is not doing anything most of the time. You have different threads here. You have the spin here, the red. So when you see this, the red, so here is the spin and the overhead. You have a big spin here waiting for something. We don't want to go deep on the application. Just to explain what the application is doing. It's going to take a lot of time, and just giving you some information about how we can see the logs and weight analysis and how we can interpret the information that we have. So we have a spin here. When we see everything is red here, wait time by thread, it's a huge red here, which is not a very good sign. We can go to the color collie, the same thing, a lot of red colors, different functions. Top down, same thing. We have a lot of red for the wait time, total by thread concurrency, and for the platform, we can see that actually the CPU here. See if I see the CPU time here. We can see here mostly the CPU is not doing a lot of things. Okay. Let's say this is the logs and weight we have. We have a big spin here. We check the button app. We talk to the developers, and then let's see what I can do here. Yeah, and then we go to the code. Yeah. So the idea also is to move this blue bars to the OK area to take more advantage of the parallelism. CPU cores, actually they are not utilized here. The spin time is the wait time during which the CPU is busy. And actually we saw this on this red thing here in one of the threads, the video thread. And the source code is this one. Actually, where I have the line exactly, if I return back, show you the here. Let's say I'm here. I click. Hopefully, I can see the okay. Actually, it's up. Yeah, I need to. Yeah. Here I need to do the configuration for the.
Looks like it's video next spray.
Yeah. Yeah, here. So we have this one. We have this one. Let's return back again. I think it's this one. The lock is here. The P thread is, yeah. So the P thread mutex lock is this one. And this is the function is responsible. So when I click, I have this. So when you click, you go to the source code, and you have, it's going to take you directly to the line where you have the mutex. So, and it kind of is protecting this pixel calculation. So this is, and the CPU is spending time just doing nothing, spinning actually here in this mutex thread lock. And in this example, we just comment the P thread here. This one, and this one is kind of removing the lock, but it's more complicated than that for real application. But if we do that, we are going to, let's say we did that, we collect the data again, and then we have this. When we finish, we have this result. And then when you compare, let's give you just a comparison between this and this. First before, so this is with the 26 seconds with the lock, and this is the 14 seconds after removing the lock. Just to give you an idea, after tuning the application, how it's going to get a huge impact on the performance in time of the elapsed time, the wait time too. So same thing when you see the spin time from 3.35 seconds to 1.89 seconds. For the CPU usage, it's not much, but as you can see here, for example, we are using almost, I think it's going to be more threads here, or almost the same. 10 seconds, yeah, here we're using actually three threads mostly, but here we are using 2. Here it's about the type of application which is not taking really advantage of the CPUs. But the second thing is when you see the synchronization object, the critical section here was on the top with 357 seconds with a 509 wait count. Now it's disappearing. Actually, it's going to the 1st, 2nd, 3rd, 4th, and the 5th position with 5 seconds and 393. And the auto, another function which is on the top now, which is a really good sign of performance optimization. Any questions?
Can we see the,
For the before and after?
no, can we see the timeline?
Yeah. So yeah, this is when we see there's a lot of red things here, which is very good. Of course, we are still at idle. The spin time, you can see it here compared to here. Let's see, let's compare actually the button up here with the button up here. And you can see that things are much better. Also the threads here, of course, you have small spin or red colors here, but actually better than this on the time. When you see here, we have 22 to 24 seconds of run here only for maybe 11 seconds, but at least we are doing some job here, some work. So the CPU is busy here. The CPU, when you compare to here, is not doing anything almost, and you have a big spin here. Yeah. Top down is also good to see different functions from the total time to different functions, time consumption.
So suggestion for the code was from developer.
Huh?
Developer.
Yeah. So yeah, this is actually another big question. Sometimes performance engineers, they don't understand the code very well, because you cannot understand the code today and then you fix the problem today, because it's actually related to how much we are going to generate money that day if there is an issue. And the 2 metrics that we are using, it's the QPS queries per second and latency. And usually when it's about the lock, it's affecting the latency, and the latency is about generating money too. So when you have an issue like this one, you need just to find the lock, remove it, and then when we see something like this, we are really happy because we could reduce. And then exactly as how I explained it, is when you see this section or any function on the top, which is consuming a lot of CPU, and it's a problem with this function going to the 5th position, it's really good. And this is how we see things when we do profiling. Okay, the good thing too also is how you compare. So comparing 2 results, the before and after. Let's say here on this specific example, we go with the logs and weights, the first one. You just select. So again, let me do it again. To compare, you just go to this small thing, compare results, and then you click. You select the first, the before. You select the second one, the after, and then you just compare. So it's going to tell you need to close the previous table. You say just yes. You want to close the two different tables, the previous tables, because you are using the same data. And it's going to give you this. So the blue is the dark blue is the first analysis with the lock. The second one is without the lock. And they're going to give you the difference between the elapsed time and also different wait time, wait count, spin time, and so on. And they see we saved actually 1.45 seconds on the spin time and 11 seconds of a total of 26 at the beginning and the 14, which is huge. I mean, in real time, if we do this with this percentage, it's amazing. It's huge. Yeah, in the critical section, same thing. So you see 509 undefined because it was really, really low. So we saved 509 wait count. And the wait time is 357 seconds, which is huge. When you go to the bottom up, here too. So here you need just to maybe make it in this way, where you compare the first with the second. Here the first on the left with the red, everything is red here, and the right one is the second data collection without or removing the lock. And then the other thing that when you click, let's say you go with this, and then you click with the, let's say the thread. I'm looking for the thread, but it's not. Looks like it's here. So when you click here, click. So you have this. You have all these functions, or libraries, or files that are connected to this. So it's really helpful. And this is very helpful also for developers who knows the function that create different sections of their code. It's really good. Yeah, and that's it for the demo number 2. Any questions for locks and what? Yes.
Is there any normalization for processor frequency or anything here?
Sorry?
Is there any normalization for processor frequency or anything here for the comparisons?
You can. There is no platform. Yeah, I don't. Yeah, they do, I think. Yeah. I think it's going to be the same frequency. If we don't see the tab here, means that there is no different thing on the frequency. It's the same frequency as before and after. Yeah. If there is an issue with the frequency, actually, even before you see, and seeing how you can observe that. So usually we have our, the frequency of the CPU when you are using the turbo or the turbo frequency, and then you compare it with the platform here. Yeah, but there's no normalization for comparing. Actually, there is no tab for platform where you see the frequency. Okay. Okay, so yeah, here what we did actually is just comment in the pthread mutex before and after, and then make it unprotected. I mean the function. This is how we remove the lock. But again, removing the lock is more complicated than this. This example, I just made it to, I just made it to make it work and functional. But removing the lock can take 2-3 days, and trying to work with the developers to find another alternative, because it's going to affect the whole rest of the code, which is not easy to manage. So not that easy. Okay, yeah, after removing the locks and waits, we have shorter wait time, shorter wait count, and shorter spin time. And I showed you this on the monitoring system in my desktop. This is the before and after, comparing result or comparing feature, which is very, very helpful. Comparing the results before and after removing the lock. Now, usually the collection, in a collection that you want to do, this is the command line. You do the amplex-ccl -collect, and then the collection type, you specify the duration, and then any application program for different type of analysis. It can be hotspots, concurrency, and locks and waits. The order is through general exploration, and then go to hotspots, and then locks and waits, with considering the overhead when you do locks and waits analysis. General exploration, this is the command line for general exploration. So amplex-collect, SNB, general exploration. But please go to the actually the documentation, because sometimes they are different. So every new technology, things are different. Every new version of a VTune, sometimes the general exploration, sometimes they do it SNB general exploration, sometimes general exploration. So it's a little bit different, but this is actually the default. This is when you try to, sometimes in your environment, in Linux environment, when you try to start with a collection, there's some restricted environment security in your operating system. It depends which one you use. but this is the command line to actually turn off the security restriction that you will be able to collect the data when you finish installing VTune. So be aware of this. And I just texted, I just put the error that I have like this. When you get this error in the future, sometimes it's different. Sometimes the folder is different. For example, here, procsys kernel and then Yama. This is for Ubuntu, and the syskernel kptr for Red Hat. Advanced hotspots, which is more advanced collection for hotspots with more information. Here, when you do collection details, here you get more stack information or memory information that can help you to understand or get more data. And most of the time, sometimes when you click, I always have this problem with VTune. When you click in this small triangle, sometimes you don't see the function down. And this is sometimes when you don't have the source code on the same folder as your VTune installation, or sometimes when you don't do actually the collection in a correct way, collecting the information or specifying collection details, stack sampling. The duration it depends. Be careful with the duration. Sometimes it's crashing your server or application. When you go with a big duration, then it's sometimes bad. Be careful also with the duration, because sometimes you save a lot of data, and your storage will be, if you have a limited storage, then it's going to be a problem. So try to find the trade-off or a compromise between your storage and also representative data that you are looking for. Here you can collect data running a script. For example, with advanced hotspot, for or granularity of the sampling of 10 seconds, and then you have your script, and your script can get applications, can get, for example, you start benchmarking. You can mix between profiling and benchmarking in this situation, where you put in your script starting the spec 2017, for example, and see the interaction of different benchmarks with your CPU, and at the same time profiling. It's really good. It's nice to see how you can benchmark, understand what's the score of your CPU, at the same time profile. Yeah, I think we are good with time. Here, advanced hotspot, this is like a really simple advanced hotspot with the duration 10, but at the same time you can go, I actually put this because you can get more information, of course, the sampling interval, and then you have the collection details with stack sampling or more information. Search dir, it's for your binaries that you use. Sometimes you need binaries and symbols to see the details when you click on your monitoring interface in your desktop. And then here you need to attach to the PID or the specific process. Tell me.
In the
Yep.
previous slide, we mentioned sampling interval equal to 10 and duration as 30. So will it be taking like 10 samples per second, or is it like 10 samples during that entire duration?
What's your question about the 30? 30 is the time of your...
Duration is the 30 seconds.
30 seconds, yeah.
And over there you have mentioned sampling interval equal to 10.
Yes.
So this is 10 samples per second, or is it 10 samples in the entire duration?
So, no, it's going to take the 10 and then the 10 and then the 10. So it's going to be for the 30 seconds. For
Every
interval.
second it will take 10.
Yes. Yeah. Frequency here, I think this one doesn't exist anymore. I don't know, Steve, the frequency. But before I used to collect the frequency because of the all the frequency issues that I passed by on the Intel CPUs, just to collect and see if it's healthy or not. And actually, it was helpful. But the frequency, I think, is through the Ivy Bridge and plus, not before that. Attaching to the process too, locks and waits again, and memory access. This is a very powerful actually analysis. And just for this, I think it's going to, this is a lecture of 1 hour and 30 minutes for the memory access analysis, because it's really, really helpful. especially when you have issue with memory, because it's going to give you all the details, memory bandwidth, latency with your memory, and then, yeah, so it's memory access here. You can do it remotely, or you can use this memory access knob, analyze mem object true, with a duration of 60 seconds, and it's going to give you something like this. I wish I could do another demo with memory access too, but this is how we works with memory analysis.
What can this analysis tell you? Like, what's a typical result you get out of this?
So it's going to give you the latency and the bandwidth of your memory if it's about the issue, if it's about a memory issue in your application. Let's give you an example, very good example actually. I passed by maybe 2-3 months ago. NUMA, for example. This will give you NUMA issue if there is a NUMA issue with your application. For Java application, when you do garbage collection and memory heap, the memory heap will show you this. You do garbage collection on this, and then you give you also the memory performance information. So it's going to tell you, okay, if you play with your memory heap between, let's say, 48 gig to maybe 72 or whatever for the memory heap, this will help you increasing or decreasing the memory and specifying this memory heap for Java. Then this is the best thing to do.
To see if it made any difference.
Exactly, yeah. If it has some impact on your garbage collection and how many objects and memory, this will help.
So you might see this and tell the developer that you might see that it's the NUMA issue you said.
Yeah. So when the developer come to you and tell, oh, actually I'm missing, I have a 128 gig memory. I think I need to increase it because of my application. You just tell them, okay, can you run our application with VTune, or we help them to do it. And then if we get this result, everything is fine with memory access analysis, then you don't need memory. You have some problem either with your application or maybe with the CPU or anything else. Yep.
It does cache utilization?
Yes, cache utilization too. Cache misses, cache hit, everything, yeah. I think you can see one of the... Yeah, you have read and write. So the bandwidth, read bandwidth, write bandwidth. Yeah, I wish I could, I don't know how, yeah, LLC misses here. You have how many loads, stores, yeah. Okay, yeah, more hardware tools. So okay, VTune is not the tool that you use for a continuous profiling, which means that it's not. I mean, if you hit 120 seconds, 300 seconds, 360 seconds, then you are limited by the storage or application, or actually the granularity of your collection or data collection. So for this, you can take another maybe tool, which is Intel Platform Profiler, that you can do it for 13 hours, of course with less information data than VTune, but it can help you in a lot of stuff. I think Intel Platform Profiler is good to get some presentation or something that can help you to understand more and how you can use it. Intel Application Performance Snapshot and Storage Snapshot is just different names, but almost the same thing, except the storage, more details on the storage and performance snapshot. And then you have the VTune for containers and VMs. Here's the long and short performance analysis when you need to use VTune or any different other performance tools, depending on your application or your system, and also if it's a one application running or full system load with different tools that I added, and how we are going to use Intel VTune, for example, snapshot or storage or general exploration for advanced collection, and also when you use Intel VTune for advanced collection and the full system load. I want to mention this because it has been a huge work with Intel to actually add the Java performance feature with VTune. And I think when Gary left for retirement, then we started working on this.
There was some there already, but it was
Yeah.
more.
So in 2018, I think the version 2018 was the version with the VTune for Java. And it was since then, it was really helpful to profile the JVM, the garbage collection, all these things, especially when Java programming language is the top one. So this is the garbage collection interface on VTune. The same thing, you have your threads. The only difference that is going to show you when the stop the word or garbage collection is running, and then you have different logs that you can see them. This is actually the logs and waits analysis with Java application using garbage collection. These features are added on especially the GC profiling and memory profiling too. Since you asked the question about the memory, these are the Java performance goal. So we through VTune for Java, we try to provide more support, not only using the VTune, but also any other profilers that can help understanding the problem, finding the issue, and then tune the application for monitoring as well, and then improve the system efficiency for different application through different Java application. Within performance engineering group at Verizon. And as we saw that there is a huge increase because of the dynamic memory allocation for the Java, then we decided to really care about the Java application and especially the Java profiling or performance in general. Here the garbage collectors that usually developers they use. There's a new one. And also there's a new one. So mostly it's the garbage first or G1, and actually it's actually supported by the Intel VTune. Here the very good methodology that we I set up to Java profiling, installing SAR for 1 minute resolution, just to be more precise. Disable hyperthreading just to eliminate the CPU issue or CPU performance issue. Check the memory, especially with garbage collection and Java applications in general. Check the traffic in different servers, means that we compare different servers and see what's the situation. Is it about only one server or all the server or the bucket or the cluster? Reduce and increase the Java memory heap and understand what's the proper or what's the specific memory size for the memory heap for this specific application, and do the garbage collection profiling. Check if it's not a memory leak, which is a very famous issue. Garbage collection type, as I said, serial, concurrent, or J1 type of and the J1 is more about 64 gig memory and up of memory heap. JVM version, it's really important. Remote memory access or NUMA, disable or enable the NUMA functionality in Java is very, very helpful. We had a lot of issues fixed by this. Work with developers for Java code optimization, and then check the Java crash file, the core dump, and then profile using VTune, but not only VTune, any other profilers can help profiling the Java or garbage collection, specifically for the Oracle tools. This is one of the example of the memory heap where we played, increasing and decreasing the memory heap size and see how it's going to affect on our metrics, which is latency and QPS. When we go with 90%, it's out of the memory and you have a high swap. So it's really about the compromise between how you do garbage collection, how many objects you create, what about the reachable objects, the forgotten objects, or they are causing the memory leak and so on. So with 50% memory, then you have less time of garbage collection, and is going to affect in one of the applications that we have here actually. And the libjvm, it's actually the responsible of the garbage collection, and you can see it on Java. And we tried instead of most of the time, see when you see this one was before and after, but libgvm was more than 4.50 seconds. It was actually maybe 100 or 150 seconds. And after fixing the issue, the libgvm reduced a lot, which means that the garbage, instead of executing the garbage collection most of the time by the CPU is trying to execute the compiled Java code or the real application itself. Conclusion, good profiling or cool profiling habits. I think it's about finding and eliminating the waste, the wait time, find the area to tune, understand the system limits, solve a problem issue, locate the bottlenecks and the latency, and the most important thing is to build this modular architecture either on your program, application code, system, and also hardware. For people who work with Java, minimum number of objects. Try to don't create a lot of objects, and then you will have problem with garbage collection and memory leak and all this kind of problems. The memory heap is really important, so try to find the best size for the memory heap. It doesn't mean that you have more memory, it means that you give more size for the memory heap. Tune the memory usage on your application. Every application is different. It's different not only for memory heap, but also for the garbage collection version that you use. Really important. And then use the Java memory profile tools, VTune for Java or Intel VTune Amplifier, but also Visual VM, gprofile, Java Mission Control, and your kit are also different enterprise profilers for Java. Where to go next? I think we are done with profiling. Profiling containers maybe is going to be a good idea too. Performance with Linux, Java performance, and also performance. And the benchmarking is going to be part of the software performance of the science of performance. Thank you very much, and this is my contact information if you need to, if you have questions, yeah, go.
So, in your experience with these tools and stuff, how much is the percent of optimization that we are actually able to, kind of gain by using these?
Yeah, it depends actually. For me, I did actually a study of hardware and software. Let's say I would just talk about software. If I do the benchmarking, what's going to help in percentage if I change things? Let's say if I do different compiler or different version of compilers. Sometimes I have 2 to 3% gain if I change the compiler. If I go with let's say using specific library to boost something in the memory, is going to help with 5%. If I go with different operating system, sometimes we don't have any gain. Once we were working on jumping from Red Hat 6 to 7, how is going to help? Is it the kernel difference? It's going to help in optimization? Sometimes it's 0. In some specific application, it's like 15%. So the answer to this question is the same as a profiler. If you ask me the question, okay, if I use different profilers or I use the VTune, how much I'm going to gain? So VTune is going to give you the area where you need to optimize. This is the issue. This is the area where you need to optimize your code. Now, how much? It depends how many loads you have, how many servers you have, how many requests you have. If it's a database, if it's a simple application, if it's front-end, back-end application. So I cannot tell you the number, but if you do a deep profiling and find the issue, we have one of the case where we got the QPS was at 270 QPS. We were hitting 2,000 QPS. It's huge. It's not about only VTune profiling, but VTune was helpful to profile the application, but the tuning too. So it's going to show you where to optimize your code. At the beginning, when I didn't know about VTune, I was thinking, okay, I just need to run this application and then it's going to tune my application. It's not like that. It's not, the application is not going, except if you do some artificial intelligence maybe, using some code that's going to help to optimize or tune your application. It's about profiling. If you are good, if you have a good habit in profiling, then you can gain a lot in optimization. Yeah. Any other questions? Gary.
No questions.
Yes.
Most of your jobs short-lived or long-running?
You mean if it's emergency or not? We work in some emergencies or projects.
You showed an initial example where you're running the program from the command line, but I think you also had some examples where you were attaching by PID.
Yes.
So are most of the Java programs that you said that your workload is comprised of running for a long time that you'd have attached to?
Yes.
For a while, or
Yes. Sometimes, okay, the developers, they always push for a long-term analysis, which is a collection of 360 and above, and more. But we don't like it. As a performance engineering group, we don't recommend this. If you have an issue, you can find it by maximum of 120 seconds. You can get very representative data, add in maybe more features like collecting the stack information, and you can get the issue right away. If you go with 360, long-term analysis it's a bad thing. Sometimes you crash your application. Sometimes you crash the server. Sometimes you limit your storage, which is bad. So I did 360 seconds, which is one of the maximum analysis I did, and it's resource consuming a lot because take it in a way like 1 minute of Intel VTune is 1 gig to 2 gig of data. Yeah, it's 1 gig to 2 gig of data. If you do the stack information, it can hit 2 gig of data for 1 minute, which is 60 seconds. If you do 360, then yeah. And don't forget that you are, everything will be in OPT, so OPT/OPT/Intel. Or if you want to put it somewhere else, then it's going to be maybe helpful.
Ideal architecture to be actually, running this kind of an application. Is it like you install this on a server? Is this actually, also doable in a client server kind of a thing where you install it on a server and then just provide it some kind of a feed of an application or something, and then it points to the particular location? Because the way that you're describing that in 60 seconds, 1 GB of data is going to get collected.
Mm-hmm.
If I start doing it on an individual laptop or something, it will, may not.
Well, I mean, laptop is not for the high tech or like a distributed system. It doesn't make any sense that you install it in your laptop. Laptop will be here just to monitor the analysis. Mostly it's going to be on servers. Now, answering to your question about the architecture, it's heavy to install the collector in the server, even with all what Intel is doing. They have a new project where you can run the agent. For me, how I do it, when I have issue on the server, then I will install it. I don't install it by default. It's not going to be one of the packages when I create a server, which means that with the operating system and put everything there. No. I install it when I have issue, and sometimes when you have issue, you don't have access to the server. Sometimes you install it in the production, which is bothering the application. So it's heavy to install it, and you install it only when there is an issue, and then you collect the data. You don't finalize the data on the server. You just do the monitoring on your desktop. To don't bother it, because finalizing the data and creating the big report on the server is going to take a compute and storage. So I do it in my desktop to see the data, and then don't bother the server, especially if it's in production. Now the next project, the big project that Intel is trying to do is small agent that you install, and then is going to communicate with a server that you build. And then the agent is going to run for continuously, the same way how Intel platform profiler. And then when you need more data, then you just collect the data the same way how we are doing right now.